Hello, welcome to another section of Math. Today in this video we'll be looking at how to solve this integral problem here using use substitution and then trig sub. Use substitution will be for the first part and then the other part trig substitution will just take over. Okay, or we just apply trig sub on the other part after the use substitution has been done. Well, if you wish to pause the video and try, you can do so. Other than that, let's just get started. Okay, so first let's write our solution. Alright, now let's bring this one down here. As I said, we are going to do substitution. Okay, so you're going to let u be equal to the whole of square root of x plus 6. Okay, so substitution. So let's write the equation for you. That is u is equal to square root of x plus 6. Alright. Now let's square both sides. Now when you square both sides, you're gonna get u squared is equal to x plus 6. Okay. Now let's differentiate. When we differentiate this, you're gonna get 2u du, and then this one will give us what? Dx. So you're gonna get 2u du is equal to what? Dx. This one is going to replace the x in the u world, and then this one will replace this one in the u world. But what is going to replace the other one? That is square root of x plus 5. So let's make x the subject from this equation and then know what is going to replace the other one. So when you make x the subject, that is, we're gonna bring this one to this side, and x will be equal to u squared minus 6. So u squared minus 6 is equal to x, Alright, now let's replace them in the u world and let's see what we are going to get. Now after replacing them, this is what we have got it. Here is going to be square root of u squared minus 6. This one is replacing what? X here. This one replaced what? This x. So here minus 6 plus 5 will give us what? Minus 1. Sorry. And then this, here we're having u, and also here we're having u. So this and this will cancel out and to be left with what? U. Okay, so when this and this cancel out, you're gonna get 2 times square root of what? U squared minus 1 du. Alright, now let's bring this constant outside here. Alright, so what are you going to do here? That is square root of u squared minus 1. Well, we should do another substitution. Doing another substitution will not work, won't help us. I think what will make our work, or what will help us move faster, is what? to go for the trig substitution was approach. So here we're going to use what trig sub, that is trig substitution. You can also say trigonometry substitution, you are not wrong. Now with trig sub, you would need what? A right angle triangle. So let's draw a right angle triangle. Good. And here I'm gonna put the angle what? Theta here. So let's put theta here. Good. So here we are subtracting 1 from what? U. So you're gonna bring U here. You know, this plus this will give us what? This. So since we are subtracting this 1 from U, it means we have to put our what? U here. Okay, so you're gonna put U on the hypotenuse side. So here will be what? U, and then we will put this 1 here. Forget about the minus. Put this 1 was on the adjacent side. We put what? The 1 here, and then here to get this side is going to be U squared minus what? 1 squared. Then we take square root of that, and that will give us what? Square root of U squared minus 1. So let's put our U here, and then let's bring our 1. To get this side is what? This squared minus this squared, or square root. Okay, and that is what's coming here. Good. Now, how are we going to know the ratio that is going to what? Replace U, or the whole of square root of U squared minus 1? Well, I've told you that always go for what? Easier ratios. I mean the ratios with formula that what is simple to what? Differentiate. Okay, so here what about cosine? Let's find out. Cos theta will give us 1 over what? This. 1 over what? This. That is 1 over U. And you know, to differentiate, it will give us a little bit problem. So what about when we decide to, reciprocate both of them? That is going to give us 1 over cos theta is equal to 1 over 1 over U. And so we are going to get secant theta is equal to what? U over 1. And that will give us U. So let's use the reciprocal of what? Cos theta. Okay, so we're going to get secant theta is equal to U. Now let's differentiate. Now when you differentiate this, you're going to get secant theta tan theta the theta, and it's equal to what? Du. You know, when you differentiate U, you're going to get what? Du. Good. Can we get any ratio that can replace the whole of square root of U squared minus 1 without substituting secant theta into the square root of what? U squared minus 1? Yes, it is possible. You know, in my previous video, I decided to ignore that part and show you how to substitute the ratio into what? The square root sign, and then work with it. And then the other time too, I decided to show you how you can get another ratio that can what? Replace it. Here too, I'm going to do the same thing so that we can go fast. Sometimes when you realize that you can get another ratio that can replace maybe a whole question that you are working on directly, then just do it straight away without wasting time, because that one, will make you go fast as compared to substituting what? The ratio into the square root and then blah blah taking square root. That one will just take a little bit time. Okay, from the triangle we can see that tan theta is equal to square root of what? U squared minus 1. The formula is opposite over what? The hypotenuse. Opposite over what? The adjacent. The opposite is what? Square root of U squared minus 1, and the adjacent is what? 1. And when you do that, you're gonna get what? Square root of U squared minus 1. So tan theta is equal to square root of what? U squared minus 1. Now let's replace them and know what you are going to get in the theta world. Good. Now this is what we have gotten. This one is equal, this one is representing what? This, and then the whole of this one is representing what? This one. Yeah, we didn't get anything to represent what? This u here, but provided if we had substituted secant theta into this one, we're just going to get the same thing as what? This. Let's find out. U is what? Secant theta. So when you bring it here, it should be secant theta squared minus 1 will give us what? Tan theta squared. And when you square tan theta, when you take square root of what? Tan theta squared, you're going to get what? Tan theta. So you see this one is fast. Okay, now let's move on. This time, this one will give us tan theta squared secant theta d theta. Okay, we also know that tan theta squared is equal to secant theta squared minus 1. So let's replace this one with that. Alright, now let's open the bracket. When you open the bracket, this time this one will give us what? Secant theta raised to the power 3, and then secant theta times this one will give us what? This one, that will give us the same thing as what? Secant theta. Alright, now let's split them. Alright, now when we split it, this is what we are going to get. To split this one, we have to also multiply all of them by what? 2. This 2 is affecting this one and also affecting what? This one also. Provided we know the answer to the whole of this, it's just a matter of, after writing the answer to the whole of this, we just have to multiply it by what? 2. So if we are splitting it, answer to each of them here has to be multiplied by what? 2. Okay, that is why come these two and then these two what are there. Okay, so here we're just going to first work with this one. We're going to integrate this one. When we are done, we will move on to this one, and after getting answer to each of them, then we put them all together to know our actual answer. Okay, but yeah, let's first start with this. Okay, this one here, we're just going to split it. Okay, this one here can be written as secant theta squared times what? Secant theta. Okay, good. Here we're going to use what? It's an integration of what? Apart. So we will not be using the traditional approach. I'll try, and then in my another video try and then use the traditional approach also. I like the DI method because it's always fast for me. Here I'm going to use what? The DI method. You're going to integrate this one and then differentiate this one. Okay, but mind you, you will not carry this two odds along. You will just maintain it. Okay, and when we get the answer to this one, then we multiply it by what? 2. Okay, don't worry, what we are going to get is going to be a little bit confusing, but you don't worry. You're just going to get understanding at the end of the day. So that is our DI method. Now let's draw a format. As I said, we are differentiating this one and then integrating what? This one. Now when we integrate this one, you're gonna get what? Tan theta. And then when you integrate this, you're gonna get what? Secant theta tan theta. You already know more about DI method, though not into details, but how to get your answer and why we multiply a row. You already know about that. So here we are not going any further. We are what? Stopping. We are stopping here. Okay, because we can easily we can work on the product of what this and then what this. Okay, so let's write our answer. The first part of our answer is going to be the product of this diagonal, that is this one times this one. Okay, and then the next one is what we are going to further work on, that is the product of what the whole of this times this one. Okay, but it will be negative because it is what the negative row. Good. I, now this one here is the product of what this and then that, which is what let me indicate this in an arrow for you. That is the product of what this and that, which is what indicated by this red arrow here, gave us what this one here. And then this one here was gotten by multiplying this and this, which is in this blue parenthesis here. That is this and then this give us what is here. Tan theta times secant theta tan theta will give us what? Because we are going to further work on it, will be what? Integral. So it's going to be integral tan theta squared times secant theta d theta. Alright, so this is the first part of our answer, and this is what we are going to further work on. So let's further work on this one and know what we are going to get, and then add it to this one to know the actual answer to what our integral secant theta raised to what the third power the theta. Alright, here secant theta squared is equal to secant theta squared minus 1 is the same thing as what? Tan theta. So you know 1 plus tan theta squared is equal to what? Secant theta squared. So when you make tan theta squared the subject, you're gonna get secant theta squared minus 1. So and that one is equal to what? Tan theta. So if we are having tan theta, we can replace that one with what? This. Okay, so let's open the bracket inside here and not this square bracket. You know, because the negative here is going to affect everything that is inside here. That is why I put this one in this bracket. Okay, so let's open the bracket. When you open it, this time this one will give us what? Secant theta raised to the third power, and then this time this will give us what? Secant theta. Good. Now let's open the bracket. No, this time this one will give us negative. This time this will give us what? A positive answer. But we will just split it. Yeah, when you open the bracket, this is what we are going to get. That is secant theta tan theta minus integral secant theta raised to the third power d theta plus integral secant theta d theta. Now what are we going to do? This one is not actually equal to the whole of this because we are having some integrals out here that is not making the answer what complete. Okay, but we know that this one is the same thing as this one, so we're just going to add this one to this, and then we also know the answer to this one, that is what the natural log of absolute value of secant theta tan theta. Okay, so we're just going to send this one to this side and then add it to this one, and that will give us what? 2, because it's what? It's a like term. Okay, so you're gonna get 2 you're gonna get secant 2 multiplied by integral secant theta raised to the third power d theta is equal to secant theta tan theta plus natural log absolute value secant theta plus tangent what theta. All right, this one here 2 integral secant theta raised to the third power d theta. This one here is just the same thing as the original question that we are what, not the main question, but after applying the Trig stuff, we came to get something like this one, but there was constant 2 which was multiplying all of them. After splitting it, we came to get something like 2 like this, and then also minus 2 the whole of this. Remember in the other part, that is what we had, and we decided that let's work on this one. Let's find the answer to maybe this one alone, and when we are done, we find answer to something like this. But that one, there was 2 what multiplying all of them. Okay, so this one here is actually the same thing as what the one that we just started integrating. That is 2 multiplied by integral secant theta raised to the third power the theta, isn't it? Yeah, this was what we started differentiating, but the only issue here is that we didn't include the 2. We didn't carry the 2 along. So the answer to that one is that the answer to this integral is what, this one. So the original one to the answer to it is what, the whole of what, this. But what if I want to know the answer to only this one? Yeah, what if I want to know answer to only what, this one? You remember I said that when we get answer to this one, then we multiply it by what, the constant. But here is the case, we have got the same thing, the same problem was here. The same problem here, this is the answer to it. But what if I want to get answer for only this one? How am I going to do that? Well, don't worry. I should have stopped right the whole of this one as answer to the integral that we are just solving, and then move on to the other one. But because somebody may also think that, okay, what if I want to get this one and go by what I said initially? Well, if you want to do it that way, this is how you are going to go by. You are just going to make the only this one the subject by taking these 2 off. How do you take it off? You multiply both sides by 1/2, and when you do that, this one will go off, and then whatever you get on this side will be the actual answer to this integral. Let's do that and let's see what we are going to get. So let's multiply 2 by 1/2. When you multiply 2 by 1/2, 1/2 times 2 gives us 1. So you're gonna get this integral here will be equal to the whole of this times 1/2, and that is going to give us 1/2 times secant theta d theta plus 1/2 natural log absolute value of secant theta d theta. Okay, so if you want to find the actual value to this one alone, maybe if you come across, if somebody may ask, what if I come across this one alone and I'm to integrate a problem like this without any constant at the back here? How am I going to do that? Well, to do that, you just follow the same approach. when we reach where you get that 2 here, just divide, multiply through by 1 over 2, or divide both sides by what? 2. And so this one here is the answer to what? This integral question here. Okay, so now that we know the answer to this one, which is what? The whole of this, we're just going to multiply the whole of this by what? The constant 2. Yeah, and you see that we're just going to get the same answer as what? As 2 multiplied by integral secant theta raised to the third power d theta was equal to um, secant theta tan theta plus natural log absolute value of secant theta tan theta. Okay, let's find out if you are going to get the same thing. The original one was 2 times this one. Okay, so now that we know the value of this, or we know the answer to this one, let's multiply it by 2 and see what we are gonna get. But I'm just going to repeat um 2 times integral of this one for you. Okay, so that is the repetition here. Don't get confused, because this one here is reflecting what I said earlier on, that when we get the answer to this one, we multiply it by 2. So the answer to this one is what? This. So we're just going to multiply it by 2, and that is what is reflecting here. Okay, so when this one here is equal to this, that is this 2 here, the same 2 here. What is the integral of this? That is what is here. So the whole of this one is equal to this one, but let's open the bracket and see what we are going to get. Okay, now when we open the bracket, let's find out what we are going to get. These 2 and these 2 will cancel out. The same thing is applied here. You see, after opening the bracket, we see that we have gotten the same thing as what the other one was. Okay, so if you want to get answer to this one alone, or if you are integrating this one alone as a main question, that is what you are going to get at the end of the day. But if something is if there is a constant attached to it, as this one is what reflecting, that is what you are going to get. Not 2, but it can be 3, it can be 4, it can be 5, it can be blah 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 blah, but it depends. Here we had the answer to be this way because the constant was 2, and that 2 just take away this half and then that of this one. Okay, so now the answer to the integral is what? Secant theta tan theta plus natural log absolute value of secant theta plus tan what? Theta. All right, now let's move on to the other one. All right, the other one is 2 times integral secant theta, and in my other video I show you how you can how after to this integral is what arrived. So here I'm not going to show those steps again. I'm just going to write the answer directly for you. Okay, so the answer to this integral is what? 2 times natural log absolute value of what? Secant theta tan theta. Okay, so we have gotten answers to each of them. Okay, so what are we supposed to do? Because we separated them, now let's put the two answers together and know the actual answer to the main integral question. Okay, so let's add answers to this integral. Yeah, here I didn't bring the a and b, as time goes on, we have to instead of a and b, you can choose also to do it this way, and they are all the same. So answer to the whole of this and also answer to this one, we're going to put them both together. So now let's put them together. All right, so the answer to this one is the whole of this, and the answer to this one is just what? This. But it seems this one and then this one are the same. And since they are the same, let's consider their coefficient. The coefficient of this one is -2, and this one is what? 1. So 1 minus 2 will give us what? That is -1. Okay, so you're going to get secant theta tan theta is equal secant theta tan theta minus natural log absolute value of secant theta plus tangent what? Theta or tan theta. All right. Now, guys, this one here is the answer to the main integral question in the theta world. In the theta world. But remember, this word helps us to solve our problem. So when we are done, we have to go back to what our or where we came from, or what the x world. Okay, and going back to the x world, remember we first passed through u world before getting into this particular world. So we have to go by the same procedure. We have to first enter u world and then x world. And going back to the u world, we know that secant theta is equal to what? U, and tan theta is equal to what? Square root of u squared minus 1. From the right angle triangle. I'm not having that right angle triangle here. That is why I decided to, write it down for you guys so that, if you are forgotten, you can see how I am getting my answers. Okay. So tan theta is equal to this one, and then secant theta is equal to u. So wherever how I come to this expression, wherever I see secant, I'll just put u there. Wherever I see tangent, I'll just put what? This one there. So let's replace secant theta and tan theta with what? U, and then square root of u squared minus 1. All right, after replacing them, this is what we have gotten, and this one also is the answer to the main integral question in the u world. Okay, this one is the answer to the answer to the main integral question in the u world, but still we have to go back to the original one. If you leave your answer like this, you are not wrong. But the question didn't say you should leave your answer like this. Neither did the question say leave your answer in the what? X word. But you choose to enter this world to solve your problem. So when you are done, you have to go back to how the problem was presented to you. Present the same thing what? To the one who asks you to solve the problem. Yeah. Okay, so we have to also continue our journey. That is the journey of going back towards the x world. And going back to the x world, we know that u is equal to square root of x plus 6, and then u squared is equal to x plus what? 6. Okay, so let's replace u squared with this one, and then u with this one, and see what we are going to get as an answer in the what? X world. Okay, so let's replace them. So this integral question here is now equal to, the answer to it is equal to square root of x plus 6 times, the dot here is representing what? Times square root of what? X plus 6 minus 1. X plus 6 minus 4 will give us what? 5. Now when you can minus natural log absolute value. Remember here was what u, and u is equal to square root of what, x plus what, 6, and then plus, the other side was just u squared minus 1, and u squared is equal to x plus what, 6. So here we're gonna get 6 minus 1 will also give us what, 5. So this one is equal to, okay, so this one is equal to square root of x plus 6 times square root of x plus 5 minus natural log absolute value of square root of x plus 6 plus square root of x plus 5. X plus what? 5. Okay, this, guys, this is the answer to this integral question here, but not the actual answer because we haven't add our hot. Yeah, I heard the other guy saying our plus C. We haven't add the constant to it. Okay, so now let's add the constant to it as a we are ending. Good. This one here, before we add our constant as we are ending, this one here, we can leave the answer like this and add our plus c to it, or from the multiplication law of set, square root of a times square root of b give us what, square root of what, ab. So this times this will give us what, square root of what, x plus 6 times what, x plus 5. And then before we add the constant, we're just going to open the bracket for this one, just multiply everything, multiply the whole of this by this, the whole of this, that is, this time this will give us what, x squared, this time this will give us what, 5x. Now we pick this one, this by this will give us what, 6x, and then this by this will give us what, 30. And so after opening the bracket for these two, we're gonna get s squared plus 5x plus 6x plus 30, and that one will give us what, x squared plus 11x plus 30. Good. Now after opening the bracket, that is what we are going to get. Okay, now we can, let's add our plus c to it. So therefore this integral here is equal to this one minus the whole of this plus c plus c plus c. All right, yeah, I know it's cool, I know it's cool, I know it's cool, but you know what, guys, if you are doubting our answer, or if you are thinking you are, maybe you are doubting the solution, or you think that maybe if I want to get this one back, by means of differentiating this whole problem, will it be possible? Because looking at all that we have to go through to get this answer here, if you are thinking of maybe either will be possible or not be possible, you don't worry, in my next video I'm just going to differentiate. I'm doing that because the workings that we gone through, or the workings that we did, how get this one be equal to taking this, added this one to this one. If you don't take care, you might think that as for this one, when you differentiate, you not get it back because of adding this one to this, taking this one here and doing this stuff, yeah, something like that. So in our next video, we are going to differentiate this answer here, that is square root of x squared plus 11x plus 30 minus natural log absolute value of square root of x plus 6 plus square root of x plus 5, and then plus our hot c. So I'm just going to differentiate this whole problem here to find out if we can get this one back. When you rationalize this one, you're gonna get when you rationalize this one, you're going to get this one over x plus 6, x plus what 6. Okay, so I'm saying that because maybe some of you might try differentiating the whole of this one, and when you do that and you get something like maybe the whole of this over x plus 6, and then you don't get this original one here, maybe you might be thinking you are wrong. You are not wrong, you are correct, but you don't worry. In that video that we are going to do as our next tutorial, or as our next video, I will try my possible best to get this original one back. I will show you where the rationalization aspect will come in, and then I will also try and show you how you're gonna get this one back. After rationalization, you are familiar with that, but sometimes getting the original one back, when you differentiate the whole score thing, and if you don't take care, you're just going to get maybe you might not get the as this one is looking, might not get it back as this one is looking, but something like square root of the whole of this over x plus 6. When you get that, you are not wrong, you are correct. But you don't worry if you don't get this one back. You don't worry. In our next video, we are going to find out how we will manipulate the rationalized aspect to get this original one back. The original one will be my focus. Okay, all right, that was just by the way, guys. Well, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.